My dear learner, for once again, we are still on number basis. It is my wish to complete every subtopic under number basis in the SHS mathematics syllabus. And for that reason, today we are going to talk of converting numerals in base 10 to other bases. Sit down quietly, take your notebook, take your pen, or any other thing which may be of help to you as you watch this video. Let's see our first question. Convert 1 base 10 to the binary or base 2. We are going to consider about two methods, and now this is the first method we are going to consider. Let's see our first step to consider in method 1. You have to write down the place values of the base required up to the highest place value, which is less than or equal to the numeral to be converted. So that is our first thing to do. Let's see. So in this question, we are going to write the place value of the base required, and here the base required is base 2. So we are going to write the place value of base 2, which are in powers of 2. So this is what we have. Now, the place values from right to left are 1, 2, 4, 8, 1, 6, 3, 2, which are powers of 2. If you still have problem, or if you have not watched my video on place values of number bases, then go back and watch that. So this is the place value of the base required, which is base 2. Now, the number to be converted is 1, 1, or literally, let's say 11. And we know that 16 and 32 are above 11. Therefore, we do not accept that. We rather ignore 16 and 32. Now, we accept the place values that are less than the numeral to be converted or equal to the numeral to be converted. We can see that we have 1 on the screen, 2, 4, 8. All these place values are less than 11 or 1, 1 you see on the screen. But 1, 6 is greater than 1, 1, and therefore we should have written the place values from 1 up to 8, ignoring 16 upwards. But for explanation, I brought these numbers. So let's move on. We accept the place values less than 1, 1. Now let's see the second thing to do. Our second thing is that we have to first divide the given numeral, which in this case is 11 or 1, 1 base 10, by the highest place value in point number 1, writing down the quotient and the remainder. So let's see what to do Now, the highest place value you see among the accepted place values is 8. So, we write 8 in front of our root sign or the division sign. Okay. Then, our numeral to be converted, as you see on the screen, is 1 base 10. So, that is 11. We write that inside the square root. So, by long division, 11 divided by 8 would give us 1. Then, we multiply 8 by the 1 on top of the root sign to get 8, as you see on the screen. Then our next step is to subtract 8 from 11, giving us 3. So the number on top of the root sign is our quotient. That is the name. Then the number gotten by subtracting 8 from 11, which is 3, is the remainder. Now we move on to our next point. It says that the remainder is then divided by the next highest place value, writing down its quotient and remainder. Repeat this process till division by 1 is done. So now we draw our root sign again. We write the remainder, which is 3, inside the root, as you see. Now we move to the next highest place value accepted, which is 4, as you see on your screen. Then we bring that 4 in front of the root sign. Then, which means that we are going to divide 3 by 4. But we know for sure that 3 cannot be divided by 4. Therefore, we write 0 on top of the root sign. Then, we multiply 4 by the 0 on top of the root sign to get 0. Our next step is to subtract. So we subtract and we get 3, as you see on the screen. Still on point 3, we are moving on. We draw our root sign again for our next step. Then we write the 3, which is the remainder, inside the square root. Now, we move to the next highest place value among the accepted ones, and that is 2, as you see on your screen. Now, 2 would divide 3. 2 goes into 3, 1, which is written. Then 2 times 1 will give us 2. Then we subtract. After subtraction, we get 1 as our answer. So still there is a remainder. Then we draw the root sign again. We write 1, which is the remainder, inside the root sign. Then it is left with our last place value, which is 1. So 1 is going to divide the 1 in the square root, as you see. 1 goes into 1, 1. 1 1 in front of the square root, multiply 1 on top of the square root would give us 1. And when we subtract, we get 0. So this ends our third step. Now let's see our fourth step. The fourth step says that write down the quotients in order starting from 2, that's our step 2, to 3 as your answer to the question. So we go back to our answers, and starting from left to right, we write those numbers as our answer to the question. That's the 1, 0, 1, 1 would be our answer. Therefore, 1 base 10 is 1 0 1 1 base 2, and that is our final answer to the question, and that is the method 1. Let's see the method 2. The method 2 is common to most students, and that is what we are going to do. Using the same question, convert 1 1 base 10 to the binary or to base 2. Let's see the second method. In the second method, the first procedure is that we should draw a table of 3 columns depicting number base, numerals to be converted, and the remainder. So let's go back and do as the procedure says. So we are drawing the table of 3 columns. Number base is indicated. Then the numeral to be converted is 1 1 base 10, that is 11, literally. So that is also written in the middle column. Then the remainder is what you see on the screen. Let's see the second thing to be done. Repeatedly divide the numeral by the new base desired, and writing down the remainder at each stage until a final 0 quotient is obtained. So the new base required is 2 in this case. We are going to divide repeatedly by 2. So this is the 2 you see on the screen. Now we are going to divide this 11 by 2, and let's see how it is done. The division sign is drawn. Good. That is 11 divided by 2, as you see on the screen. And this is going to give us 5 remainder 1. So we are going to write the 5, which is our quotient, in the second column, and 11. Then the remainder would be under the remainder column. Then we write 2, meaning we are going to divide this quotient, which is 5, by 2. So we draw our division line. Then the 5 would be divided by 2, as you see on your screen. And that would give us 2 remainder 1. Now, we again shift the 2 to the second column and then the 1 under the remainder column. We still have a quotient, which is 2, so we keep on dividing. So we write 2 again because 2 is the base required. Then we draw our division sign. We are going to divide these 2 by the new base, which is also 2. So it will be 2 divided by 2. And that would give us 1, remainder 0. Then we push the quotient, which is 1, to the second column, and then the remainder would be in the remainder column. Now we still have a quotient, which is 1 to be divided. So we write 2 again, meaning we are going to divide this 1 you see on the screen by 2. So we draw our division line again, and then 1 divided by 2, as you see on the screen. And that would also give us 0, remainder 1. As you know, 2 cannot divide 1. So we push the quotient to the second column and then the 1 to the remainder column. Because under the quotient column or the second column, we have gotten 0 now. So there is no need for us to continue again. We end there. Let's see our third procedure. Write down the remainder from bottom to top as the answer. This is quite simple, my friends. So we are done. Let's see what to do. Write the answer from the bottom. 1, 0, 1, 1 as our answer. Therefore, 1, 1 base 10 is 1, 0, 1, 1 base 2. And that is the same as we did in the first method. And then somebody would like to consider the calculations here at the right hand side as our method 3. And look at the other things you must know about that too. When we divide 11 by 2, we may get 5, remainder 1. 5 is our quotient. So we push the 5 to our second step and divide it by the new base required, base 2, because we need our answer in base 2. And that would give us 2, remainder 1. Then our quotient is 2. We push that quotient 2 to our third step, where we divide that 2 by the new base 2. And that would give us 1, remainder 0. Then we push that 1 to our fourth and final step, which would give us 0, remainder 1. Immediately the quotient is 0. There is nothing you can do again than to stop there. So we write our answer from down to top, or from the bottom to the top, as our answer. And that is 1, 0, 1, 1. So one could consider this as our third method. And when this is done, there is no need for the table. Let's see our exercise or assignment. Write 1391 in base 12. Our answer is 97B base 12. If you have not subscribed to my YouTube channel, please do so for me. Write 5 3 base 10 in base 2, and our answer is 110101 base 2. 3. Convert 444 base 10 to the base 5. And the answer is 3234 base 5. The next thing is, think of this. When you are converting numerals in base 10 to other bases, that is base B, you have to think of it as forming groups of B from the numeral in base 10. And for that reason, it deals with division. So always when you are converting numerals in base 10 to other base or other bases, think of division or drawing the table where repeated division is done. Please like, comment, share, and subscribe to my YouTube channel. See you in the next video. May God be with you. May His face shine upon you. Enjoy the rest of the day. Bye.